Okay. The two lessons that we are going to be doing today are a review from last year. The first one we're going to do is solving systems of equations by graphing. You guys just starving always? The second thing we're going to do, which should be a review, we're going to solve systems of inequalities by graphing. So systems of equations and inequalities by graphing. Okay, so it's just like the bell work. We just solved a system of equations. So the first thing you want to do, which I did not give you on the bell work, is you want to convert the equation to slope-intercept form. I hope you're writing this down. We are converting, and you might need your notebook out, and then when we go to graph, you can use the little tiny graph paper I gave you. On the bell work, they were already in slope-intercept form, so you didn't get to practice that step. Davis, do you know what slope-intercept form even is? I'll start you out. Yes. So we've been dealing with y equals ax squared plus bx plus c. We've been dealing with quadratics for like a month or two. We're going back in time a little bit to review this so that when we apply it to quadratics, it's fresh. The linear part is fresh. Okay, convert it to slope-intercept form. Once you convert it to slope-intercept form, you will graph it. And keep in mind that b is the y-intercept. It's where you begin. I always wish that the B and the M were like different letters that had to do with the y-intercept and the slope. But the mathematicians who created these spoke a different language. So the M actually means slope or rate of change. It's just not in English. So that's why they have an M there. Okay, once you plot your y-intercept, then you do your M, which is the slope. And this helps you know where you move. Begin at B, move with the M. Does this feel like a review? It should be. And if not, if there's a few people who just didn't quite get it before, this is for them, right? Because when we move on to doing it with quadratics, we want them to all be on the same page with us. And then you repeat. You do it again for your 2 lines. So we're going to do an example of this one. So on one of your graphs, on your paper, do this example. We're going to solve for y and graph it. And here's the next one we're going to do on the same graph. So write these 2 equations down. I've kept the solving for y pretty easy. On the worksheet, they're a little more difficult. Sometimes the y is on the wrong side. So Ethan, on that first equation, y plus 8 equals -3, what do I have to do to convert this to slope-intercept form? Say it again. Yes. Okay, so whatever graph you chose, and mine are going to be not that great because I'm drawing my graphs here. It's just hard to be accurate when I don't have a graph paper. I was trying to cut and paste a graph and it was not working. Okay, so we begin at -8. Brianna, where do I go from there, from that -8? up 3 over negative 1. Wait, why did you go over 1? It doesn't say to do that. Yes, it's not down 3, make a dot, down 3, make a dot. When you have a whole number for your slope, it's always run 1. So let me show you something else too. She said to go up 3. It says negative 3. So if you go down 3 and you run 1, it's way too low. I don't need to know what goes on way down there. So like Brianna said, go in the other direction. Yeah. That's your slope. Rise 3, run negative 1. Rise 3, run negative 1. Yours might look a little different than mine because I am not on a beautiful graph. I am on a man-made graph. So we begin at the y-intercept. We did rise negative 3, run 1, but that was getting so low that we applied that same slope in the other direction. I think I went a little bit too far over right there. Okay, let's go look at the other equation. Ian, what do I do on this one to get the y by itself? Yes. Question. Now, I want this to be in slope-intercept form. So instead of writing 6 plus 5x, I'm going to put the 5x first and then the 6 because it's mx plus b. I don't know that that's 100% necessary, but be very particular and you'll make less mistakes. Liza, what else do I have to do? Everything. Everything has to be divided by 2. Emma, is it okay that I have a fraction right there? Should I be concerned about that? But I don't like fractions, so can I change it to a decimal? Yeah, it would be hard to graph a decimal. Rise 5, run 2 is absolutely okay. Yeah.
So I have a question about the first question. Why didn't you go over negative 8?
Over? For this one? We've been doing x-intercepts, haven't we? We've been doing x-intercepts for like 3 weeks. So if your mind just did the same thing as Allison's, it is a y-intercept, not an x-intercept. Great catch. I wonder if anybody else did that and didn't dare ask me. Probably. All right, Damon, what do I do here with now that I've got this beautiful slope-intercept form? Yes, explain how. My y-intercept, then what? I would definitely go in the other direction now. Going up 5 and over 2 again, you're clear off your graph. That's not an important thing to do. Okay, you guys are going to have to look at your paper to see where these cross. Because mine does not seem... It looks like it's right here. Beta, can you tell us on your paper where they cross, like the perfect ordered pair? Good. Mine is way off of that. This is why I gave you a paper with graphs on it. You can't be accurate with these if you're drawing your own. Well, you can. Some people are very good at it. Clearly, it's not my gift. Okay, this is called one solution. When we are graphing systems of linear equations and we are trying to solve, this one is called one solution. We're going to talk about briefly infinite solutions and no solution. So by that graph, will you please write somewhere around it one solution? That was our example. That is the most common. Most of these will cross once. Every once in a while, you will see these. That's why I wanted to show you so you don't think you've done something wrong. Okay. Let's do an example of each one of these. So we did one solution. So pick a different graph that we're going to do this one on. And here's our two equations. The first one I kept pretty easy. Y equals 1/2 x plus 5. And the next one you need to do a little bit of solving. So graph the first one. Again, go to a different graph. Everyone should have 6 or 12 graphs. Most of you have 6 graphs. So graph that top one, and then solve the second one, and graph it. So graph that one, solve this one, and then graph it also. Just a sec. Paper. They're over there in the bins. The top bin. Good. Doing okay? Having people falling asleep. Did you write them down? Okay, I want you all to show your graph to the person who you are sitting next to. Make sure they look the same. If you have 2 neighbors, show both your neighbors. If they are shy, tap them on the shoulder. If you got it wrong, see if you can figure out. If yours are different, see if you can figure out whose is not quite right. Okay, the first line should look something like this. I really wish I had graph paper available. Allie, what do I do to get this one so that the y is by itself? I want to put it in slope-intercept form. Yes, add the 10. I think I've already picked any. What do I do now? Yes, Damon. Damon, what do I do with that? Like, I don't know how to do that slope. Okay. Now we can graph it. Does anybody notice anything right now? Did it make them nervous that it was the exact same one over here? Well, that was the point of this example. So they will always, if this is on a homework assignment, they will always put the second one in disguise. They're not just going to give you the exact same equation. That would be silly. So they'll give you the other one in disguise. You will solve down. It's the exact same line. You write infinite solutions. There's not just one ordered pair where they cross. They're the same thing everywhere. This would be like saying, Carter and Mrs. Mitchell start at her door and walk to the lunchroom together. When are they walking together? The whole time. Versus, Carter leaves the lunchroom, Mrs. Mitchell leaves her room. Where do they cross? That's one solution, right? We're headed in different directions. Always the same. Okay, let's look at 0 solutions then. Sometimes people write that little empty set symbol. So again, I'm going to give you an easy equation to start with because and then the next one you'll have to do a little bit of solving. Graph these two on the same graph. You'll have to solve the second one first. the top one, y equals negative 2/3 x minus 4. Good. Let's write these two down. Write that one down. And write that one down, and then we'll graph that first. So on your little notes paper, the graphs, make sure you have these equations written down, especially showing you solving. That might be helpful in a little bit. That's a good idea. Can you see as you're graphing these why it has no solutions? So this could be an example of like, I could say Keegan and Damon are both leaving their houses at the same time. So they both walk outside their door. They walk straight east for 10 minutes. When will they cross paths? Never. They will never cross paths. Not if they go straight east, which is impossible because there's probably houses and trees in the way. Okay, so let's go through and solve this one. Lacey, what do I do to get the y, to get this one in slope-intercept form? Yes, let's get the 2x over on the other side. I'm going to be really particular about how I write it because I want it to look like slope-intercept form. So the 3y is okay, but I'm going to write the negative 2x first. I would never mark it wrong if you switch the order, but if you wonder why I do that, it's because I want it to be in slope-intercept form. Keegan, what's the last thing I do? So I've got y equals negative 2/3 x plus 3. So it's got the same slope like I noticed here, but it's got different y-intercepts. Thank you. It's not you. So a different y-intercept, same slope. Ooh, that's hard. No solutions. They never cross. They never have a single ordered pair in common. Okay. I'm going to give you 5 minutes to start. Oh, where's the worksheet? The front side of this, there are 4. And I have to tell you, the solving, putting them in slope-intercept form is more difficult than the ones on the board because sometimes y is on the other side or something like that. I wouldn't say they're really difficult, but they're just a little bit more difficult than this. So 5 minutes so you can practice this before I teach you something a little bit different. Did you guys have a good weekend? Did anyone do anything fun? Studied? I'm glad you think that's fun. Did anyone like get together with friends or family or something? Yes, so I'm giving you 5 minutes to start on the top 4 on the homework because we're doing 2 lessons today and I don't want to teach something new before you've had time to practice this on your own. Stuck in a driveway from snow or like from people parking behind you? Oh.
Wait, turn it right here. And I turned it too late.
But so many people watch these when they're absent. Okay. You still want to convert to y, but it'll be greater than or less than. Sometimes when you are converting it into slope-intercept form, you divide everything by a negative value. Let's go through an example of this, and then hopefully we'll remember what we're supposed to do when that happens. So please write down negative 2y plus 8 is greater than or equal to negative 3x. Please write that example down. And it can be on your graph paper, because we are going to graph this. Yes, on your little white one. Keegan, what should I do to solve or to convert to slope-intercept form? Yes. Minus the 8. We're getting close. Ashlyn, what would you do next to make sure this has been converted to slope-intercept form? Yes. This is where there's a difference. Does anybody remember from first trimester what you have to think about and do when you divide an inequality by a negative? Josh? Yes. If your mind didn't automatically remember that, this is where you need to give yourself a little reminder. As you're converting to slope-intercept form with these inequalities, if during that process you multiply or divide by a negative, which we're doing here, like Josh remembered, you have to switch the inequality sign. So as I finish solving, instead of greater than or equal to, we switch it to less than or equal to. Now that's a lot to write for those of you who are writing it down. So I'm just going to pause for a minute. And some of you remembered it, so you're not writing anything down. So I'm still pausing for a minute. If while you are converting this to slope-intercept form, if one of those steps has you dividing or multiplying everything by a negative, you switch the inequality. And we explained in first trimester why, and I'm not going to take the time to do that right now. Sorry. Divided by a negative, which changes the problem significantly. Once you start doing your homework, if you've shaded the wrong side, this is probably why. Okay, we'll graph this in a minute. Let's mention the second thing that's different. I don't always use a solid line. If it's greater than or equal to, or less than or equal to, solid line, which is what we were just doing. That is not different. But if it's greater than or less than, without the line underneath, it's a dashed line. So sometimes we divide by a negative, sometimes we don't. We don't always need to have something different on step one. But step number 2, you have to ask yourself, is this a solid line or a dashed line? And then you can write this down to remember. The dashed line helps us remember that the ordered pairs on that line will not make your equation true. It would be something like 0 is less than -5. It would not be true. All right. The third thing that's different from what we just did, lots of similarities. The third thing that's different is we have to shade a side, right? So we've gotten to this point. We have our line. It's either dashed or solid. But we have to shade in the top or the bottom. So this might be an example if you've ever been to Lagoon. You can ride this ride if you are greater than or equal to 47 inches. Or, I don't know if any of you have family members who are like big football playing adults, sometimes you're too big and too heavy to go on rides. So if you are greater than or equal to this weight, you can't ride the ride. That's kind of what this is talking about. It's not just these people we're talking about, it's everyone above can also ride, or everyone below can also ride. So once you get to your line is drawn, if it's greater than or equal to, you shade above. If it's greater than, once you graphed your line, you decided if it's dashed or solid. If it's those two things, you're going to shade above the line. You could probably finish this without me saying anything. When do I shade below the line? If it's less than or equal to, you shade below. There's a reason why I'm not saying left and right. Sometimes below is on the left. Sometimes below is on the right. It depends on if your slope is positive or negative. So don't be thinking left and right. It won't work. Not for diagonal lines, not even for a horizontal line. It's above and below. Yes? Yeah, let's finish that one. Let's wait till everyone has this written down. We'll finish that one we just wrote a minute ago. We've got time. Okay, so the last equation we wrote, where we switched the inequality, it ended up with, extend my page in case someone's still writing that. So we solved it through and we ended up with it saying y is less than or equal to 3/2 x plus 4. So go choose one of your empty graphs on that white paper and write this one down. Our second equation, if you are very fast and want to work ahead, less than 6. All right, Sophie, how do I start graph? It's already in slope-intercept form. We did that a minute ago. We divided by the -2. We switched. So what do I do to start to graph this one? Yes. Then what, Sophie? Rise 3, run 2. And I don't know, you guys might have a bigger graph than me. Maybe you can rise 3 and run 2 again. But Sophie, if I only have a little graph like mine, how else, what other direction can I go to see where this line's going to head? Down 3 over 2. Down 3 over 2. It's less than or equal to, so it's a solid line. You know, get a drink, Hayden? Adelaide, how do I know which side to shade? It says y is less than, so do I shade above the line or below the line? Or less than? Below. And I just kind of do this. I am not overly aggressive with my shading. Like I am not coloring it in. Did you get that, Dana? Edwin, did you get that? We're shading underneath. Okay, let's look at the next one. Jesus, how do I, step number 1, convert to slope-intercept form. Jesus, what do I do on this one to get started on that process? Add 5x to both sides. Oh, I bet that's so loud. Add 5x to both sides. Davis, what do I do now? Divide everything by 2. Do I need to flip my inequality? Nope, I did not divide or multiply by a negative. This is just regular dividing. Oh, I should have written those the other way. I'm going to move my 5/2 x right here. I'm switching them. Peyton, what's my y-intercept? Yeah, what is my y-intercept right here? 3. And what's my slope, Peyton? 1, 2, 3, 4, 5. 1, 2. Huh. I wish my line looked so fancy, but it just doesn't. It will look better on your graphs. Alaska, which side should I shade? Above or below? Y is less than 5/2 x. Is less than above or below? Below. Do you see now why I'm not saying right or left? So there's lots of solutions that make these equations true. So let's see which it is. Our solution is where I've got it coloring twice. So in this little pizza slice right here, has it been colored twice in here? Nope, just the green. How about up here in this pizza slice? Has it been colored twice in here? No, just once. No, nothing over here. So the solution, and I usually try to like reinforce it a little bit. It's this huge part over here. This has all been shaded twice. Any ordered pair, you could choose any of these ordered pairs, plug them into your equations, your x and your y, and it will be true statements. Things like 0 is less than 5. -2 is less than 0. It'll be true statements. Any questions on this one? So many of you falling asleep. Do you have early morning baseball too? I could tell. I just look around, I can just tell all my baseball players. And lacrosse, because y'all were up at 6 too, weren't you? Did you go this morning? Heavens, I'm going to have to talk to your coaches. Not so early. Okay, I'm going to do one more example of the shading, and I'm going to do some of the really, I don't know what these are called. They just don't happen very often. Equations that are a little different because they're not slope-intercept form. So this is the last example I'm going to do, and they are a little different than, why do I have so many of these left? There must be people absent. So try this first. Try to graph these for a second before I demonstrate it. They don't have slopes. They're not really y equals mx plus b. They're missing things. They're horizontal and vertical. So see if you can remember which ones they are. And if you want a ruler to make straight lines, there's some right here. You're welcome to come get one. So again, these are still inequalities. I just wanted to show you these unique situations. Write those two down. Right here. Where does y equal 5 on your graph? Yes, just a dot. And so you go horizontal, kind of like on the bell work, go all the way across. Make your line all the way across through that dot. And then which side do you think you shade if it says y is less than or equal to 5? If it says less than, you shade top or bottom. Yeah, go ahead and shade it in. And all the way down here too. It's the whole thing. Okay, please look at your neighbors. Compare with your neighbor. Show them what you've graphed and what you've shaded. All the way over here too. Where does x equal 4?
So when the line is straight up and down, which side would you do?
I'll talk about that in a sec. That's why I wanted to do this one. Okay, do that. And this one's a vertical line like this. And it's dashed. Okay, first one is pretty easy because we did something like it on the bell work. I learned last year, I was helping out with the middle school out at South Cache, and they had something that teachers would say box and hoi, and it helped me to remember in such an easy way. If it's just an x equals something, it's a vertical line on x. And if it's just a y equals something, it's a horizontal line on y. That helped me forever to stick. So I go to where y equals 5, solid line or dashed line? Solid because of that. Am I coloring above the line or below the line? Below, because it says less than. Okay, here's the question, because I didn't talk about this one. Vertical on x. So I go to 4, dashed or solid. If you make mistakes on these, this is the most common one, because we're used to just drawing a line. So slow down a little bit if you can on that. Now, this line does not have a top or a bottom. Like, not at all, right? Are you noticing? It's got a left and a right. Haley, do you think if it says greater than, that I shade the right or the left? Think of it like a number line. So we're only focused on the number line. Like, these are negatives, these are positive, it gets bigger. Which side would you say is greater than 4? Yes. So I think if you just think of this like a number line, you don't have to memorize a top or a bottom or a left or a right. Think about the numbers, because you've seen number lines for a lot of years. Like in elementary school, we even saw number lines. So most of us, greater than 4, that's going to be to the right. So our solution is quite a bit. Our solution is all of that. Okay, I'm going to stop my recording. You should have enough information to work on this worksheet. Oh, there's one thing I needed to show you. On the bottom of the front page, it says write the inequalities for the following graphs, but you can't tell which side was shaded. It was so light in the original that when I photocopied, it went away completely. So will you please go in and shade these sides so you can then write the inequality? You can't see it on your, again, it's at the bottom of the front page, and it says to write an equation, and then you can't see which side has been shaded. So I wanted to... This is not the front. The holes are on the left. On the back. Oh, I don't like that the holes are on the wrong side. Okay, let me stop the recording and then I'll walk around.
It's like the front, the ones that we did first are on the front.
So it is definitely numbered weird. So this was supposed, here, let me stop it. Nobody wants to hear this part of my lesson.